Hi, this is Ben Tupper. The Cat and Mouse Puzzle. You are a cat trying to catch a mouse. The mouse is hiding in one of 8 holes. You may check any mouse hole. If you don't find the mouse, you may keep checking. If you do find the mouse, you can eat it or become friends. Here's the catch. The mouse doesn't stay put. After each check, the mouse moves stealthily one hole over, either to the right or to the left. This move is invisible to you. After each check, the mouse always moves to an adjacent hole, never moving more than one away, and never staying put. What is your best method for catching the mouse? Pause and think, and come back when you're ready for an answer. Are you ready for the answer? I'll explain the solution to this puzzle in 2 parts. First, we'll construct a chart, a visual method of representing this cat and mouse game over time. Once we're solid on that, I'll show you my winning strategy. Let's start with the representation. We'll design a chart that can describe the mouse and cat over time. This row of 8 squares represents the 8 mouse holes, and the blue letter M represents the mouse's position. Here, he's in the second hole. We can add additional rows if we want to graph the mouse's location over time, during the cat's first check, second check, and so on. Reading this chart from top to bottom, it describes a mouse that started in hole 2, moved to hole 1, then moved back to hole 2, then to 3, then 4, then 5. We can use the letter C to mark the holes that the cat checked. Here, the cat checks 6 times and never finds the mouse. Notice that the cat is allowed to check non-adjacent holes across turns, as well as checking the same hole twice in a row. Make sure you understand this representation, because we'll need it in order to talk strategy. Let's start by looking at 2 specific cases, and then we'll generalize. Here, our mouse starts in hole 2. His next move can either be to hole 1 or hole 3. Here, our mouse starts in hole 5. His next move can be either to hole 4 or hole 6. These are both instances of a simple but general fundamental rule. If the mouse starts in an even number hole, his next move must be to an odd number hole. Conversely, if the mouse starts in an odd number hole, his next move must be to an even number hole. Using this observation, we're going to simplify this problem by splitting it in 2. First, we'll consider strategy, assuming that the mouse begins in an even starting hole. Then we'll consider strategy, assuming that the mouse begins in an odd starting hole. Finally, we'll use both of these strategies together to find a strategy that's sure to catch the mouse no matter what hole he begins in. Let's do the evens first. Assume the mouse starts in an even number hole. That's 2, 4, 6, or 8. We'll use these blue M's to keep track of all the possible spaces the mouse may be hiding. Where can the mouse be on check 2? We're assuming he's coming from an even hole, so he's going to an odd hole. That's 1, 3, 5, or 7. And on check 3? Yep, an even number hole. And so on, alternating to create a sort of checkerboard pattern. The dark squares on this checkerboard illustrate the mouse's possible locations at a given time. We can imagine the mouse's movements through time as a checker piece, making diagonal moves from the top of the board downward, always staying on a black square. So here's a simpler challenge. Placing one check in each row, how can you be sure to catch a mouse that starts in an even hole? That is, how can you stop a checker piece that stays on black squares from descending? Hint: don't waste time on white squares. Hintier hint: it can be done in 6 checks. Here's how. Place 6 C's in this diagonal pattern. A checker piece that starts on a black square must hit a C within 6 checks. No matter what path he takes. And of course, a mouse starting here would be caught immediately. Stepping back from our checkers metaphor, what this means for our mouse is that if he is an even starting mouse, he will surely be caught in 6 turns, so long as we follow the checking pattern 2, 3, 4, 5, 6, 7. That's half of the problem. Let's consider strategy for when the mouse begins in an odd starting hole. An odd starting mouse would start in an odd hole, move to an even hole, and back and forth and so on. In other words, an odd starting mouse would start on one of the white squares of the top row and remain on a white square throughout. We could catch him using almost exactly the same checking pattern, just backwards. 7, 6, 5, 4, 3, 2. Unfortunately, we can't execute the 2 patterns simultaneously. We're bound to just a single check per turn. How do we combine the 2 strategies to make sure we catch the mouse no matter where he starts? Although we can't implement both strategies at once, we can implement the 2 strategies back to back. Say we start with our even strategy. If the mouse started in an even hole, we'll catch him in the first 6 turns. If we reach check 6 only to find that we still haven't caught him, we know he started in an odd hole, which in our checkerboard diagram is a white square. This means we know where he is on the 7th check, on one of these white squares, in an odd numbered hole. With this knowledge, we can begin our odd strategy. 7, 6, 5, 4, 3, 2. By check 12, we will have caught the mouse. Here's what the 2 partial strategies look like back to back, together forming a comprehensive strategy for the cat to use to unfailingly catch the mouse. But maybe they'll just be friends. P.S. A friend sent me this video of his cat trying to catch a mouse. Someone needs to teach this cat our strategy.